All right, ladies and gentlemen, so here's what we've got today. Today we're going to talk about arithmetic series. Now, the main difference between a series and a sequence is that in a series, you'll notice that there are plus signs between each one of these things. So what happens is we're trying to find the sum of however many of them. Excuse me. So when we have these, we're talking about the same thing you have in arithmetic sequence, 4, 7, 10, 13, 16, 19. You'll notice that each one of them are going up by 3. So you still have the common difference and all that, but the difference, the main, whether it's a sequence or a series, is the plus sign versus just the comma. So there's a formula for finding the sum of however many terms you want to look at. So what we say is the sum of however many terms for the n number of terms is always going to be equal however many terms you want, and then it's the first term plus the rule a sub n. This is the rule from the sequence. We'll come back to that here in a second. All over 2. Okay? Now remember, the nth term, how you find that was this. We did this one yesterday. So when you're working with series, you're going to wind up using both formulas here. Anytime that we have a series that's arithmetic and we have to find the sum of something, first thing I always want us to do is write out the general rule for the nth term, because you're going to have to use this nth term in here at some point anyway. So that's our first step. Now, here's what a question would look like. A question like this one would say, we'll call this part A. Find the sum of the first, we'll say 30 terms. Okay? So we know that we have to figure out the sum of 30 of them. Okay, this is where this n value of 30 comes into play. So first thing we do is we come back over here. We got to figure out the nth term. Its first term, which is 4, plus, well, we want to find 30 of them, so we know it's going to be 30 minus 1, and our times our difference. Well, our difference between each one of these was 3. Okay? So our 30th term is going to equal, well, 29 times 3. And then we add 4 to it. Our 30th term is 91. Okay? So we know that our n value is 30. So we have 30 times the quantity first term, which is 4, plus the nth term, which was 91, all over 2. Okay? Go back to our fancy schmancy handy dandy calculator. 30 parentheses alpha y equals, going to make a fraction, 4 plus 91 all over 2. Close your parentheses and hit enter. The sum of the first 30 terms will equal 1425. Okay? Now there's a second part to these problems that we're always going to see is like this as well. And I'll just put this on a clean sheet. We'll use the same sequence here. Same series. We had 4 plus 7 plus 10 plus 13 plus 16 plus 19 plus blah, 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 blah. We had our rule. A sub n was 4 plus n minus 1 times 3. So this became 4 plus 3n minus 3. So this became 3n plus 1. That was our nth term rule. Okay. Now we know that the sum of so many terms was n. First term, that's a 1. A sub n all over 2. So the second part of these questions usually will be this. Find the value of n such that the sum of that value of n equals 175. Basically, this is what we're trying to do is how many terms within the sequence would we have to add together to get 175? So what happens here is we know, excuse me, we know that we want this value to equal 175. We have to solve for n. So we know that our sum is 175, and that has to equal n times our first term plus the rule a sub n all over 2. All right, well, we know what our first term is. It's 4. And we now know what the nth term rule is. It was the 3n plus 1. So what we do is we start piecing these things together. So we have 175 is n 4 plus 3n plus 1 all over 2. Okay. Do a little combining of like terms inside the parentheses here in the numerator, and we get 3n plus 5. So we have 175 is n times 3n plus 5 all over 2. So now we have to figure out how do we solve this out? Well, we got to multiply both sides by 2, and I get what is that? 350 is n times 3n plus 5. Okay. So what now has to happen is we have to distribute 3n squared plus 5n, and then I got to set aside equal to 0, so I move the 350. And what we do from here is we have a quadratic. And I don't know about you, but there is no way I want to factor that. So we're going to do our fancy schmancy search for it in the table now. Once we get this, we go right to our table. We enter this in, 3 squared plus 5n minus 350. Then I go to my table, and I'm looking for a value of finding my zeros. Oh, there it was. Notice, I need to have a positive 0 here, a positive value of n, because if this was, because you're searching for zeros, because if I go the other direction, I'm going to get negative numbers. I can't add negative values. I can't add negative 12 of these together or whatever to get down to 0, but I'm looking for my 0. And you'll notice you find your 0 right away at 10. When n equals 10, you get a 0, which means if I added 10 of these together, 4, 7, 10, 13, 16, 19, what would it be, 21, 24, 27. If I add all those up for the first 10 of them, I'd get 175. And that's what we're looking at doing today. It's a little bit more work on this second part when you're trying to find this, how many you have to add together. But just remember, whenever you're working with these, even though it's a series, you're still going to have to utilize the idea of getting the rule for the nth term, because you're going to have to substitute it into here at some point in time. Okay? Give these a shot, and we'll do some geometric stuff tomorrow. Hope you guys are all doing well. If you need anything, just let me know. Thanks.